Right, year 11. So continuing on from the first video, which we talked about indefinite integrals in exercise 17E, I'm just going to do a few of these problems in case you're feeling a bit unsure about them, just to make sure that you know how to do. So let's do question 2. So now that you know how to antiderive, you're going to sort of see the purpose now, okay? So here we go. What's this question asking us to do? So let's think about it. They're telling us that the derivative of the original function gives me this. Okay, and they tell you that in the original function, so f of 0 gives you 0. Essentially, they're saying if you sub 0 into the original function, f of x, then the y value is 0. That's essentially what they're saying. They say find f of x. Now, what you have to remember is f of x is the original. To get f dash of x, that's the derivative. Okay, so don't forget you found the derivative by going forward. So if you want to find the original function to go backwards, you have to antiderive. True? So if you antiderive the derivative, so really I'm just saying antiderive the derivative, it should give me the original function. True? So if you think about it, I derive to get here, then I antiderive to get back. Okay? So in our case, I've got antiderivative of the derivative, which is 4x cubed plus 6x squared plus 2 dx. Okay. Now, hopefully you've practiced enough to antiderive these individually. So let's antiderive each one. So again, with this one, it's a, which is 4, x to the power 3 plus 1 over 3 plus 1. Antiderive the next one, so plus 6 is the a value, x to the power 2 plus 1 over 2 plus 1. Plus, hopefully by now you know the antiderivative of 2 will end up being 2x. Don't forget when you're doing the antiderivative, there is a plus c, okay, because we didn't know what c was. But remember, if you antiderive all of this, this should technically give you f of x, because that's what we set up here. True? We said it should equal to f of x. So now let's simplify this. You got 4x to the power 4 on 4 plus 6x cubed on 3 plus 2x plus c. 4 cancels out with 4. 6 divided by 3 is 2. And so this gives you x to the power 4 plus 2x cubed plus 2x plus c. That's my f of x. Okay? So what I've just done is I've antiderived I'm going to just color code it. So I antiderived my derivative and it went backwards and I found f of x. This is my f of x. Okay. Now, how do I find c? Well, they had to tell me something, and they did. They said that if you sub x in to f, which is the original function, so if I sub x equals 0 in, the result should equal to 0, which is technically saying y equals 0. So if I go back here, if I sub x equal to 0, meaning that all these have 0 in it, that sub 0 in there, then the results should all equal to 0. That's essentially what that means, right? So I'm going to sub 0 into each one. So it was 0 to the power 4 plus 2 times 0 to the power 3 plus 2 times 0 plus c. And remember, all of this is meant to equal to 0, because that's what they said. They said equals to 0, equals 0. Okay? So if we do that, it just so happens that it becomes 0 plus 0 plus 0 plus c equals 0, and it nicely gives you c equals 0. So what does that tell me? They said find f of x, which is the question. So I've got x to the power 4 plus 2x cubed plus 2x, and I just found out c is 0, so that's my answer for question 2. Okay, so really the skill in this one is to realize that when you're finding the antiderivative, you're going back to find the original function, but remember there's a problem because we don't know what the plus c is. That's why they have to give you a coordinate. Okay, let's do another one. Let's do okay, you know what? Let's do question 3. I know it looks tedious or at least weird, but trust me, it's the same drill as question 2. Okay, so let's have a look at question 3. Same drill. Here we go. So it says if the gradient, which is keyword gradient at a point, so it's at x which we don't know what the coordinate is, on a curve is given by this. So essentially what they just said is the gradient, if the gradient equals to 6x squared. That's what they just told me. But remember, this is the gradient function. Another way of writing gradient is derivative. True? Or if you want, you can write f dash of x equals to 6x squared. Okay, that's what they've just told you. And it tells you that the curve passes through 0, 12. They had to give you a coordinate. So they're just telling you that the derivative of a curve, so I don't know what the curve is. Let's say that's the curve, okay? Let's say that's the curve. They said the derivative, f dash of x, is equal to this. That's what they told us. But how do you find the derivative? You find it by doing differentiation. Now, they said as well the curve, which means the original function, which we don't know what it is yet, the curve passes through 0, 12. So it means when you sub x equals 0, y equals 12. Very similar to question 2. Okay? So, well, I don't know what f of x is. I don't know the original function, but I know I can find it because the antiderivative of your derivative should give me the function. Okay, so I'll write it again. The antiderivative of the derivative, which is the gradient, it should give me the original function. So I'll write it again. Antiderivative of the derivative, dx, should give me the function. Okay, so I'm just doing exactly the same as question 2. So antiderivative, what's the derivative? It's 6x squared. So let's work out the antiderivatives. In this case, it's pretty simple. A is 6, x to the power of 2 plus 1 over 2 plus 1. Don't forget the plus c. So if you rewrite it, that becomes 6x cubed on 3 plus c, which is essentially 6 and 3 cancels out. So 2x cubed plus c. Remember, what is this all equal to? You just found the original curve. Okay, so don't forget, you started off with an original curve, you found the derivative, which is f dash of x. So the only way to get back to the function is you antiderive the derivative, and it gives you the function. That's why I know it's f of x. Now, I don't know what c is, but they did say that apparently this curve, okay, so 2 times x cubed, this curve passes through 0, 12. So what does that mean? They're just saying that this curve, when x is 0, the answer to it should end up being 12, which is your y value. Okay, a lot of students don't realize f of x is the y value. Okay, so if I do it all again, it says 2 times 0 cubed plus c, but remember, it's meant to all equal to 12, because they said 0, 12, didn't they? They said when x is 0, y is 12, and f of 0, so when you sub 0 in, the whole result should equal to 12. Okay, but if we solve it, that becomes 0 plus c, and it just so happens that c equals to 12. So what's my curve? What's the final function look like? Well, f of x now is equal to 2x cubed plus 12. Okay? That's essentially what question 3 is doing. It's exactly the same as question 2, just worded differently. Okay? And if you have a look at question 4, similarly, it's the same too. Okay? It's the same drill. So here we go. If I just picked 4e to do, same drill. Let's have a look. Let's look at 4e. They said that in 4e, find y in terms of x. So really find y, which is y equals to something with x in it. So they told me the derivative, dy dx. See, they just told you the derivative. So if we did e, the derivative is equal to 2x to the power 4 plus x. So you can see if you want to find the original function, then you have to antiderive to get back. So the antiderivative of 2x4 plus x dx should give me the original y function. That's what it should mean. So let's have a look. Antiderive 2x to the power 4 is 2x, 4 plus 1, which is 5. I'm just speeding up the process now. Plus, now this is x to the power of 1, so really it's x to the 1 plus 1, which is 2, so 2, don't forget the plus c. Okay, so this is my equation, right? And this is what they said. They said y equals 0 when x equals 0. So that means y equals 0 when x is 0. So you got 2 times 0 to the power 515 plus 0 squared on 2 plus c, and you can see this ends up being 0, 0 plus c, 0. C equals to 0. So now what's y? Y is actually now equal to 2 over 5 x to the power 5 plus x squared on 2 and c 0. So that's it. Done. That's question 4. Okay. Essentially, that's what you need to know. That's what you need to understand. There's more in exercise 17 to challenge your understanding a bit further, but learn up to this step because that's what's mostly on the exams to understand: derivative, antiderivative, indefinite integrals, and then later definite integrals. Okay. Hopefully this video helps. I'm going to stop here and then I'm going to talk about definite integrals in the next one. Okay.